Hello, second period students. You need your spiral and you need to title your notes, converting repeating decimals to fractions. We're doing this lesson on a video since you missed class today due to the assembly. Tomorrow we're going to be going over the lesson that you should have gotten today. It's a little bit more challenging, so I wanted you to be in class to hear that lesson. So this lesson is actually Friday's lesson, and we'll be going over Thursday's lesson on Friday when I see you again. Okay, so again, your title is Converting Repeating Decimals to Fractions. Remember, you can pause this at any time if you need to catch up on your note taking, but anything you see here, you need to be writing down in your spiral so you have good notes to use. All right, so there is a trick to writing repeating decimals as fractions and then the other way around, and it's called the nines trick. So you see in problem number 1, you need to write that down, 5/10 being repeated. So the first thing you want to do is to put the repeated number or numbers, in this case there's just one number being repeated, you put that in the numerator of your fraction. Okay, so this would have a 5 in the numerator. Then figure out how many numbers are being repeated. So again, we just have one number being repeated here in this problem. So that's how many 9s we want in the denominator. So we're going to put 1 9 in the denominator. And then finally, you're going to check to see if you need to simplify the fraction. 5/9 is already in simplest form, so that's our answer. So 5/10 repeated as a fraction is 5/9. All right, look at number 2. In this problem, we have two numbers that are being repeated, the 7 and the 2. So that goes in our numerator, 72. And step 2, how many numbers are being repeated? Well, we said 2. That means you need 2 9s in your denominator. So 99 is in your denominator. Then we need to simplify here. We have a common factor of 9, so I'll divide by 9. And in simplest form, 72 hundredths repeated is equal to 8 elevenths. Okay, again, make sure you're writing down these examples. All right, now if you're given a fraction going back to a repeated decimal, look at your denominator. There is a factor, 11 is a factor of, we can multiply 11 by 9 to get a multiple of 9 in our denominator. Okay, so changing the denominator to a multiple of 9, in this case it would be 99, and we would multiply the numerator by 9 as well. So 5 times 9 is 45. Now, this 99 tells us that we have two numbers that are being repeated. And those two numbers that are being repeated are the 4 and the 5. So just working backwards here, our decimal would be 45 hundredths repeated. So again, look at your denominator, see if you can make it a multiple of 9. In this case, 11 times 9 is 99, so we have two 9s in our denominator. Multiply the top by 9 as well, and we have 45 in our numerator, and that's what's being repeated. Number 4, there's my little note. And number 4, 33, I can multiply 33 by 3 and get a multiple of 9 in my denominator. So I'm going to multiply the numerator by 3 as well, and that would give me 63. So this tells me I have two numbers that are being repeated because I have two 9s in my denominator, and those two numbers that are being repeated are the 6 and the 3. So this would be 63 hundredths all repeated as a decimal. All right, now number 5 is a little bit different. So write down 1/11. Again, we know that we can multiply 11 by 9 to give us a multiple of 9 in our denominator, and I would do the same thing to the numerator, times 9. Now, we have two 9s in the denominator, which we all know that means I'm going to be repeating two numbers in my numerator. But if you look at the numerator, I only have one number. All that means is that there is a leading 0 out in front, and that is what is being repeated as well. So this decimal would be 9 hundredths all repeated. So again, if there's one number in the numerator, but two 9s in the denominator, that means there's a leading 0 out front that you don't see, and that's included in your repeating decimal. Okay, think about this. True or false? 9/10 all repeated equals 1. I want you to pause the video and I want you to write down whether you think that's true or false. Write down the problem, write down whether you think it's true or false, and kind of think about why you're saying it's true or false. So go ahead and pause. Okay, now I'm going to explain. If we use our nines trick, we see that we have one number being repeated, and that number is 9. That goes in our numerator, and since it's one number being repeated, we put 1 9 in the denominator. And then our next step is to simplify the fraction. Well, doesn't 9/9 simplify to 1? So this is a true statement that 9/9, because it never ends, it never terminates, there is really no gap between that and 1. So they are equivalent. Okay, your homework that either me, Miss White, or Miss Hunter gave you is actually Friday's homework. We would only like for you to do the front of the homework, the side where you're converting the repeating decimals to fractions and percents. The back you need to wait to do until Friday for this weekend so that we can go over the lesson that you missed today during class. So you won't be able to do the back, you will be able to do the front. Please have that completed when you come to class on Friday.